Well, consider the two functions arctangent of x, arccotangent of x, with the following graphs. Arctangent looks like that, and arccotangent looks like that. These two graphs intersect at a single point, and we want to find an angle of this at this intersection. So first we want to find a point of intersection. So we want to solve the equation arctangent of x is equal to arccotangent. In this simple case you can guess the x value, but in a more formal way, we have seen that the sum of these two expressions is a constant function equal to pi half. We have shown this by considering the derivatives, which are opposite functions. So the sum of derivatives is 0, so the sum of the functions must be constant. And the constant is pi half. So we have arctangent of x is pi half minus arctangent of x. So if we add arctangent of x, we have 2 arctangent of x is pi half. If we divide by 2, we have arctangent of x is pi over 4. So x star, the x coordinate of the intersection, will be tangent of pi over 4, which is 1. And then the y coordinate will be arctangent of 1, which is pi over 4. Or 45 degrees, if you like. Here the asymptote is at pi half, and this asymptote is at pi. So we want the two derivatives, f1 derivative, and the derivative of arctangent is fraction 1 over 1 plus x squared. If we evaluate this at x is 1, we have 1 squared is 1, plus 1 is 1, so we have 1 half. And similarly, f2 derivative, the derivative of arccotangent is minus fraction 1 over 1 plus x squared, which when evaluated at x is 1 is minus 1 half. So we can either find alpha and beta from these two values of derivatives, or we can use the formula for the tangent of the angle directly. We can try both. So alpha is arctangent of 1 half, and beta is arctangent of minus pi half, which is because tangent and arctangent are odd functions, then we can write this minus in front of the function, so we have minus arctangent of 1 half. And then the angle phi, alpha minus beta, is arctangent of 1 half minus arctangent of 1 half, which is 2 times arctangent of 1 half. Or we can use this formula and we can substitute 1 half for k1 and minus 1 half for k2, and then tangent of phi will be 1 half minus 1 half divided by 1 plus 1 half times minus 1 half. Minus gives plus, 1 half plus 1 half is 1. And here we have 1 half times minus 1 half is minus 1 quarter. 1 minus 1 quarter is 3 quarters. So we have 1/3. and then the tangent, then the angle will be arctangent of 4/3. Which looks different than this result, but it is absolutely the same. If you want some numerical value, this happens to be 0.927 in radians, or approximately 53 degrees, which is in quite a good agreement with the picture. And this formula can be used to derive the relation between the slopes of two orthogonal lines. If we have two orthogonal perpendicular lines, that means with the angle 90 degrees, then if phi approaches 90 degrees, tangent of phi approaches plus or minus infinity, and this happens when the denominator of the fraction goes to 0. So, for two lines which are perpendicular, the product k1 times k2 plus 1 must be 0. That means k1, k2 must be minus 1. So we come to the important formula. If we have a graph, and at a point we consider the tangent with the slope k sub t as the slope of the tangent line, then we can consider the line going through this point, which is orthogonal, which is perpendicular to the tangent, 90 degrees, and we call it a normal. So this is the slope of the normal. And this is the slope of the tangent. Well, from the linguistic point of view, here we have two, well, slightly unpleasant situation. The word tangent means the line, the straight line that touches the graph, has the same direction. But also tangent is the name of a function, which is not completely unrelated, but two different things. Function and a geometric object, straight line, tangent to the graph. And also, the word normal is dangerous. In ordinary language, normal means something with no special property, right? But this is a line with one special property, namely being perpendicular to the tangent, right? So don't be confused with the meaning of these words in mathematics and in ordinary language. So if the product of the slopes of the tangent and normal is minus 1, we can write it as k normal. So once again, the slopes must be in product to minus 1. That means we can find the slope of the normal as minus 1 over slope of the tangent. Well, this is quite in a good agreement with the common sense. If the tangent goes up, the slope is positive, the normal must go down, the slope will be negative, and vice versa. Also, when the slope is only slightly increasing, then the normal must be sharply decreasing. Low, high, or low, high, high, low. And vice versa. If the tangent goes very quickly up, then the normal will go down, but quite decently. Let us practice this relation to find an equation of the tangent line and equation of the normal line for some function. But before we do that, let me clear the blackboard.